Let's dig in further into z-scores, or more kind of a review, but um, for our study guide for z-scores, once again, about what to do when we have z-scores. Basically, how to use our graphing calculator to assist us on finding the z-scores and what do they actually mean. So first, if I wanted to find the exact percentage of the amount or the area between and I already know my z-score, so let's say I wanted to know what my z-score, or like the area is between let's say negative 0.15 and uh, zero point 0.8. So I would just press second uh, distribution, which is vars, number 2 for normal CDF, and I know my z-score already, so that would be negative 1.5, and then 2 comma. So this is saying the area between negative 1.5 to let's say my z-score being 0.8. So this would be that area, or the probability that your z-score would land in there. That gives me a 0.72 z-score, or in terms of percentage-wise, it is a 72%. But okay, so what if so now let's talk about apples. So let's say we're an apple farmer, and the mean or the average amount of crops that we get per apple every single year is 500 apples. So that's the mean. That's how much we get on average every year. But it deviates, right? So we have a standard deviation of 75 apples. So we could have 75 apples less, or around 75 apples, more or less, in terms of deviation. Uh, so let's try to think about what are the chances that I get apples. Let's say I get 615 apples. So let's draw a standard deviation, right? And let's think about this visually. Well, our mean is already 500. We want to know how much would it be if we had 615 apples or more. So if I had to draw this, we want this amount. We want the tail end of our normal graph here. So then we take that into consideration when we use our graphing calculator. I wanted the chance of me getting 615 apples or more. Well, we can use the normal CDF. Normal CDF 615. It wants the lower bound. My lower bound is I want 615. Upper bound, I'm going to make it really, really high because I want it to just be more. So I'm just going to press 99999, and then it wants the mean and standard deviation. The mean is 500 apples, and our standard deviation is 75 apple standard deviation per year. So that says that I have a 6% 0.06. So that's my so that gives me a 6% chance of getting that many apples or more. Okay, so now what if I want let's say if I want a range of apples, right? And I want to say, well, instead of just saying 615 or more, I say I want to get what is the probability of me getting a range of, let's say, 475 apples to 583 apples this year. So somewhere between at least that much and at most that much apples there. So I know I want this, right? I want it in the middle. So then I can go back to my graphing calculator. So what if I want to, the probability that I get between 475 apples to 583 apples? Well, same thing here. Normal CDF, lower bound would be 475. Upper bound now is 583, and 500 is my average amount of apples. 75 is the standard deviation of apples. So the probability of getting that many apples is actually pretty high, 49.6 or 50% chance of actually getting that many apples in my bumper crop, between that many apples. So then next, I want to see what is the chance of, let's say, I have a very devastating year, right? My crop fails, or not fails, but let's say devastating. I don't get enough to make enough money in most cancer cases. So let's say I have, what are the chances? I have 300 apples and less. So then I go back to my graphing calculator, and let's think about what is the chance that I get less than 300 apples. Same thing here, second distribution, normal CDF. If I want less than 300, right? So would my lower bound be 0? Because anything less, you could have 0 apples. Upper bound would then be 300, comma 500 for my mean, 75 for my standard deviation. And it says, well, actually, it's a low chance, only a 0.38 or 0.4% chance I only get 300 apple crops based on my standard, based on the amount of standard my data set. But let's think now. I want to think about what does it mean for me, what number, right? What number in here, if I want to fall like at an exactly 80%, right? What number of apples I have to be at my 80 percentile range here. So then I go back to the graphing calculator and think about something differently. What if we want to know how many apples would I have to get, right? Well, how many apples I have to get to be within the 80 percentile. So then now I just go to a different one. This is second distribution, but now I want the norm, right? The norm says I want it to be in the 80 percentile. So that means the area is what, 0.8. My U mean is 500 apples. My standard deviation is 75, and that gives me, say, I need to have 565 apples to be in the 80 percentile of all my apple pickings.